All right, Calc BC Unit 2, Day 0 assignment, which I gave you guys to work on the day of the test. So that was page 66, problems 38 to 50 even. So not that many. So I don't know, 38 gives you a picture. I'm going to go and just redraw it and then ask a bunch of questions. So -1 goes up to 2, goes over to 3, and then there's a solid dot here, and it goes like that, and there's open dot up here, goes like that, solid dot here, open dot here, solid dot here, solid dot here. So this was the graph. All right. So then just ask you a bunch of questions about this problem. So A says, what's the limit as x approaches -1 from the right side? So approaching -1 from the right side looks like it's approaching 1. Right? B, limit. Oh, these are true or false. It says which are true, which statement is true, which are false. So this is what they gave you, and it was true. So part B says limit as x approaches 2 of f of x. They're saying does not exist. Well, 2 from the left and right side does exist. So this is false. I want you to tell me if it's false. I want you to fix it. It should be 1. That should be what the answer is. C, limit as x approaches 2 of f of x equals 2 is what they said. No, that's one we just did. False. It's supposed to equal 1. So I want you to tell me why it's false and fix it. D says limit as x approaches 1 from the right side equals 2. From the right side, nope, it equals 1. False. All right. E, let's see, I'm going to just do it up here. E is limit as x approaches 1 from the right side equals 1. Yes, that is true. F, limit as x approaches 1 of f of x, it says does not exist. Does not exist. Well, yeah, from left and right sides, 1 doesn't agree, so this is true. G, limit as x approaches 0 from the right side says it equals the limit as x approaches 0 from the left side of f of x. Is that true? Left and right sides approaching the same thing? Yes, they're both approaching 0, by the way. True. H, limit as x approaches c of f of x says it exists, and it says at every c on -1 to 1. So does the limit always exist between -1 and 1? Are there any jumps or holes, discontinuities? Nope, this is good. It's true. It does exist everywhere there. And then I, the limit as x approaches c f of x exists at every C in 1 to 3? No, it doesn't exist at 1. Well, that's fine. It doesn't exist at 2. That's the main one. So this one's false. All right. So that's 38. 40. I'm going to try and fit up here. Give them a picture of a graph. So I'm going to try and make a quick graph of this. And so the graph kind of looks like that. And then looks like there's an open dot up here. It goes like this. So there you go. Now, the problem says, use the graph to estimate the limits in the value of the function or explain why the limits do not exist. You have to explain why limits do not exist. So at A, it says limit as t goes to -4 from the negative side. From the negative side, that's 5, right? B, the limit as t approaches -4 from the right-hand side, superscript plus, there should be g of t here, equals 2. And then the limit as t approaches -4 in general, that's a two-side limit, we're going to say does not exist. No limit does not exist. Because the two sides don't agree, right? So the reason it doesn't exist is that there is a jump discontinuity. That's why it doesn't exist. Jump discontinuity. You could even be more specific and say the limit as well. You could just say right here the limit as g of t approaches -4, -1 doesn't equal the limit as t approaches -4 superscript positive g of t, right? Because 5 doesn't equal 2. All right, D says g of -4. Well, that's just the value of the function. So whatever the dot is 2. So that's 40. 42, 44, like that. So 42, got a picture. I guess this is S on this one. So just replicating this graph real quick. Dot there. Goes like that. Solid dot there. Goes like that. And graph kind of goes like that. Okay. So A says the limit as S approaches -2, superscript negative of P of S. So as we approach -2 from the left side, it approaches 3. B, the limit as S approaches -2 from the right side is 3. So C, the limit as S approaches -2 as a two-side limit equals 3 because they both equal 3. And then D, this is separate. This didn't have to be true, but the value of the function there is 3. That would just make it continuous. But if there was an open dot there, we still would have got answers A through C the same. 44. Do a quick sketch of this. There's an open dot there. And the graph kind of looks like this. Graph goes like this. And there's a solid dot right here. And this is y equals g of x. So A says limit as x approaches 2 superscript negative g of x. So as you approach 2 from the left side, the answer is 1. B, limit as x approaches 2 from the right side is 1. And since they agree, then the limit as x approaches 2, g of x is a 2-side limit, is going to be 1 because they both agree. And then D, separately, the value of the function doesn't have to equal 1. In fact, this time it equals 3 because there's a jump. Okay? All right. 46 and 48, it says match the function to the table. So there's a little bit of work you need to do. And so I'm just going to write both of these down real quick. This is multiple choice. Now here's the deal. Some of these tables have errors in them, and some of them don't. Error probably means that there's a hole in the graph, but you could also try and figure out what the function should be going towards if you take the hole out. So I would try and factor the hole out first, if possible. That one doesn't have a hole. Okay. But when you plug in x equals 1, you get division by 0. This one, let's see, plus 1 or minus 1, x plus 2. That one doesn't have a hole either. So these have vertical asymptotes at x equals -1 and vertical asymptote at x equals +1, which means the graph should blow up as it gets close on both sides. So if you're looking at the tables, we want one of them that looks like the values are getting bigger and bigger and bigger when you get close to it. So you'll notice this one, these are going to 0. These are getting big as you get close to that. These seem to be close to 3, right? Not blowing up. These seem to be getting close to 0. Okay, at +1. So then the other thing to realize is that this vertical asymptote's at +1. So we're looking for one that blows up. The only one that seems to be blown up is B, right? So that's B. And then 48 at x equals -1, it blows up. But none of these graphs have -1. At x equals 1, if you just plug 1 into this, you get 0 times 3/2, which is 0. So it should be one that's going to 0. And and not give you an error, right? So that would have to be A. A is the one that goes to 0 and doesn't give an error. This one's going to 0, but it's not defined there. So this one has to be A. So just a little bit of work, you can figure out which one's which. Okay, and then the last question is 50. And it says to assume that the limit as limit of f of x as x approaches b equals 7, and the limit as x approaches b of g of x equals -3. Okay, and so here on part A, we're going to do the limit as x approaches b of f of x plus g of x. So one of the properties of limits is that you can break them up. So you could say, okay, well, this is the limit as x approaches b of f of x plus the limit as x approaches b of g of x separately. And so then we can say, oh, well, that's That's 7 plus negative 3 equals 4. And part B says, okay, well, what's the limit as x approaches b of f of x times g of x? Well, same idea. Properties and limits say that you can break these up and say, well, that's going to be the limit as x approaches b of f of x separately times the limit as x approaches b of g of x separately. So that's just going to be 7 times negative 3, which equals negative 21. And then C says the limit as x approaches b of 4gx. Well, properties and limits say that you could bring that 4 outside of the limit because it's just a constant. So that's going to be 4 times negative 3 is negative 12. And then D says the limit as x approaches b of f of x over g of x. Well, properties limits say that you could take the limit as x approaches b of f of x separate, divided by the limit as x approaches b of g of x. And then if you plug these values in, that one's going to be positive 7 over negative 3. So I'd write the final answer as negative 7/3. So properties and limits. That's it. Just a little quick review to get your mind back in the limit game, and then we'll do the unit the day one notes and get a little more into it.